Hi, I've had a number of people ask me whether I can do some GCSE past exam papers. So I'm starting with summer 2017, which was when they started the new style GCSE grade 1 to 9 papers. I've got the Pearson Edexcel exam board, and we're going to do paper 1, which is the non-calculator paper. Question 1. Work out the value of 2 to the power 4. Well, this means 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, times another 2 is 16. Question 2. Write 7.26451 correct to 3 decimal places. Well, 3 decimal places would be 1, 2, 3, would be these 3. So we look at the next digit, the 5. So if it's less than 5, we just keep it at 7.264. If it's 5 or more, we need to increase this by 1. So that's going to become a 5. So we get 7.265. Question 3. And part A. Simplify 7 times E times F times 8. Okay, well, we've got numbers and letters. Let's multiply the numbers together first of all. Well, 7 times 8, well, we've got 8, 16, 24, 32, 40, 48, 56. So we've used the 7 and the 8. And then when it's the times the letters, we don't need the multiply sign. We can just put 56 E, F. And in fact, let's write that on our line here. Part B. Solve x over 5 equals 2.5. Well, the first thing I'm going to do is the 2.5. I'm going to change that into a decimal. I'm going to write that as 2.5. Well, if it's x divided by 5 equals 2.5, we're going to move this across. And when we move it across, it goes from being divided by 5 to times 5. So we've got 2.5 times 5. Note, I'm leaving the decimal point out for now. I'm going to put it back in afterwards. 5 times 5, 5, 10, 15, 20, 25. Put the 5, carry the 2. 2 times 5 is 10, plus the 2 is 12. So we've got 125. Remember, we had 1 decimal place here, so we put the decimal point in here. And we've got 12.5. Question 4. Write 4/5 as a percentage. Now, you might know this straight away, or you might know what 1/5 is as a percentage and then multiply it by 4, which is great. If not, you can think, well, if I want to make it a percentage, 4 over 5, and then I multiply it by 100. Okay, and then we can do division first or the times first. Let's do the 4 times 100. So 4 times 100 is going to be 400, but we've still got to divide it by the 5. So we can then do that using the bus stop method. How many times does 5 go into 4? Well, 5 doesn't go into 4. What about 5 into 40? 5, 10, 15, 20, 25, 30, 35, 40. So that's 8 times. 5 into 0 goes 0 times. So 4/5 as a percentage is going to be 80%. Question 5. Work out 60% of 70. Right, well, let's start off by doing 10% of 70. Well, if you want 10% of something, you can just take a 0 off the end. So it's just going to be 7. And if we want 60%, that means we want 6 lots of this. So if you think 10% times 6 is going to be 60%. So we want 7 times 6. Or 6 sevens. We've got 7, 14, 21, 28, 35, 42. So you can see with these non-calculator papers, it really helps to either know your times table straight off or be able to work them out nice and quickly. Question 6. Sammy spins... Actually, let's move it up so we can see. I can just about get it on. Right. Sammy spins a fair 4-sided spinner. So fair means that all 4 of these have an equal chance of coming up. On the probability scale, mark with a cross the probability that the spinner will land on B. Well, we've got 1, 2, 3, 4 squares. 2 of them are a B. So 2 out of 4 would be our probability. Hopefully you'll see that we can simplify this, divide top and bottom by 2 to give us a half. So we can put our cross on a half there. And we'll move it up a little bit for part 2. On the probability scale, mark with a cross the probability that the spinner will land on F. We can just about see the spinner there, and we haven't got any Fs on there. So that means it's impossible. So it must be 0. Okay. Question 7. Fahima buys 2 packets of bread rolls costing £1.50 for each packet, a bottle of ketchup costing £1.60, and 3 packets of sausages. Fahima pays with a £10 note. She gets 30p change. Fahima works out that 1 packet of sausages costs £2.30. Is Fahima right? You must show how you get your answer. Okay, so a couple of different ways of working this out. What we're going to start off by doing is adding up the cost of what we know the price of. So we know there's 2 packets of bread rolls costing £1.50 each. So we want 2 lots of £1.50. Well, I'm going to split it up and think, well, 2 times 50p is going to be £1, and 2 times £1 is £2. So we're going to have £3 in total. Okay, so basically we're doubling 1.5 to get 3. Then we got a bottle of ketchup costing £1.60. So let's add these up. I'm going to put zeros in there so we've got something to add. So 0 plus 0 is 0. 0 plus 6 is 6. 3 plus 1 is 4. So £4.60 for the things that we know. Now, we could take this off and find out how much money we've got left and work out how much the actual price of a packet of sausages is and compare it to this. Or what we can say is, well, let's assume that she's right and see if we get to the same answer as them. So I'm going to go with that approach. So we're saying 3 packets of sausages at £2.30. So 3 lots of £2.30. Well, in fact, I'm going to write it this way. So 3 times 0 is 0. 3 times 3 is 9. 3 times 2 is 6. Okay, so if she's got her calculations right, she's got 3 packets of sausages cost £6.90. So we had £4.60 for the rolls and the ketchup, plus £6.90 for the sausages. 0 plus 0 is 0. 6 plus 9 is 15. Bring the decimal point down. 4 plus 6 plus 1 is 11. Well, she paid with a £10 note and got some change. This is more than £10, so Fahima is wrong. There's no way she's going to be able to pay for that with a £10 note and get change. Okay, question 8. Work out 5/8 times 3/4. So because it's times, people often think this is more complicated, but actually times with fractions is very straightforward. We multiply the top, so 5 3s or 3 5s, 5, 10, 15, and multiply the bottom. So 4 8s, 8, 16, 24, 32. And we can write that over here. Now we've got 2/3 minus 1/4. Well, let's give them the same denominator. Well, what number does 3 and 4 go into? well, 3 times 4 is 12, so that means they both go into 12. 3 goes into 12 4 times. That's times 4. So we're going to multiply the top by 4 as well. 2 times 4 is 8. So we're saying 8/12 is equivalent to 2/3. We've still got our minus. Now we're going to do the same with this side. Well, to get from 4 to 12, 4, 8, 12, we're multiplying that by 3. So we need to multiply the top by 3. 1 times 3 is 3. So here we're saying 3/12 is equivalent to 1/4. Now, because the denominator is the same, and I could have written it as 8 over 12 minus 3 over 12, but we can also write it this way. We've now just got 8 minus 3, which is 5. Denominator stays the same. And let's put that on our answer line. Question 9. Sean works for a company. His normal rate of pay is £12 per hour. When Sean works more than £8 a day, he is paid overtime for each hour he works more than 8 hours. Sean's rate of overtime pay per hour is 1 1/4 times his normal rate of pay per hour. On Monday, Sean worked for 10 hours. Work out the total amount of money Sean earned on Monday. Right, so, well, he did work more than 8 hours, so he worked 10. How many more? Well, 10 minus 8 gives us 2. So 2 hours extra. Well, actually, let's work out. We know that he did 8 hours at £12 per hour. So let's work out how much for those 8 hours. 8 times 2, or 2 times 8 is 16. 1 times 8 is 8, plus 1 is 9. So £96 for the 8 hours. Now he's got his extra 2 hours. Now, instead of £12, he's going to get paid 1 1/4 of 12. And I'm going to write this 1 1/4 as 1.25. I just find it easy to think of it as a decimal. So we want 1.25 times 12. Okay, I'm still going to treat it as a quarter, but I just think it's nicer to write down. So 1 1/4, well, the 1, so it's going to be 12 plus 1/4 of 12. So we want 12, 1/4 of it, we're going to divide it by 4. 12 divided by 4 is 3. So we've got 12 plus 3, which is £15. Now that's per hour. We know he did 2 hours of overtime. 2 times 5 is 10. 1 times 2 is 2, plus 1 is 3. So we've got the £96 for the 8 hours, plus £30 for the additional 2 hours. 0 plus 6 is 6. 9 plus 3 is 12. So we've got a total of £126, which we can write down here. Question 10. A farmer has 20 boxes of eggs. There are 6 eggs in each box. Write as a ratio the number of eggs in 2 boxes to the total number of eggs. Give your answer in its simplest form. At first this sounds quite complicated. I think there's lots of words. But what we want is, we want a ratio, but we want the number of eggs in 2 boxes. But if there's 6 in each, we want 2 lots of 6, which is 12. So our ratio is going to be 12 ... something. Okay, so it's the number of eggs in 2 boxes to the total number of eggs. Well, the total number, we've got 20 boxes with 6 in each. So we want 20 times 6. Well, we can ignore the 0, do 2 times 6 is 12, and then put the 0 back on. So our ratio is 12 to 120. However, it says give your answer in its simplest form. So we want to find common factors of these two numbers? Well, I can see 12 here, and I've got 12 with a 0 on the end. So I know that this is 10 lots of 12. So let's divide both by 12. Well, 12 goes into 12 once. And we've just said 12 goes into 120 10 times. Because 10 times 12 is 120. And that's what they're after. Okay, question 11. A sequence of patterns is made from circular tiles and square tiles. Here are the first three patterns in the sequence. So pattern 1, pattern number 2, pattern number 3. How many square tiles are needed to make pattern number 6? So we've got to look at what's going on with our numbers here. So we've got pattern numbers. In fact, I'm going to do, how should we do this? So we've got pattern number. So we've got 1, 2, 3, 4, 5. We're going to keep going. That's the pattern number. Then we want circular tiles. And then we're going to have square tiles. So on pattern 1, we've got 1, 2, 3, 4 circular tiles, and we've got 1 square tile. For pattern 2, we've got 1, 2, 3, 4, 5, 6, 7, 8 circular tiles, and 1, 2, 3, 4 square tiles. For pattern number 3, circular tiles, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And for square tiles, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could draw some more pictures if you're not seeing a pattern yet, but I'm going to have a look and see if there's any pattern from these. Well, for me, the circular tiles, it looks like it's going up by 4 each time. 4, 8, 12. So I'm guessing this would be 16. And 20. In fact, let's see if there's a pattern. Well, how would we get from 1 to 4? Well, looks like we're just multiplying by the pattern number. Because 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. And so on. Okay, so we're going to multiply by 4 to get the number of circular tiles. What about the number of square tiles? So pattern number 1, we got 1 square tile. 2, we got 4. 3, we got 9. Well, this is looking like we're squaring the numbers. Because 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared would be 16. Okay, so I'm going to put x squared to show that we're squaring these. And I say, if you wanted to check, you could draw the next pattern and actually work it out. So that's to find out what the relationship is. How many square tiles are needed to make pattern number 6? Well, so square tiles, we're saying that we're squaring the pattern number. So for 6 of them, we think it's going to be 6 squared, or 6 times 6, which is 36. Now for part B, they're asking us how many circular tiles are needed to make pattern number 20. Well, we've said to get the circular tiles, we're multiplying the pattern number by 4. So we want 20 times 4. Well, let's ignore the 0. 2 times 4 is 8, and then put the 0 back on the end. Okay, Derek says, when the pattern number is odd, an odd number of square tiles is needed to make the pattern. Is Derek right? You must give reasons for your answer. Well, to get the number of square tiles, we saw that we're squaring the pattern number. So if we're squaring the pattern number, that means when the pattern number's an odd number, the answer, so an odd times an odd, will still be an odd number. So we can say yes. And if you want to see exactly what I mean, let's pull this down again. When the pattern number is 1, square tiles are 1. When it's an even number, we've got even. When it's an odd pattern number, we've got an odd number of square tiles again. And we'd get the same again because we would have 25 here. So we can say yes. If the pattern number is odd, the number of square tiles is also odd because odd times odd equals odd, or something to that effect. Question 12. There are only 7 blue pens, 4 green pens and 6 red pens in a box. 1 pen is taken at random from the box. Write down the probability that this pen is blue. So we're going to have a fraction here, and at the bottom we're going to want the total number of pens we've got. So 7 plus 4 plus 6. I'm going to add 4 plus 6 together first because I can see that gives me 10 plus 7 is 17. We want the probability that the pen's blue. We've got 7 blue ones, so it's going to be 7 out of 17. Question 13. The diagram shows a tree and a man. The man is of average height. The tree and the man are drawn to the same scale. Part A, write down an estimate for the real height in meters of the man. Okay, so you need to sort of have a rough idea of how tall someone should be. You could use your height if you're reasonable height. They'd give you a range of answers here, so long as it's not something too short or too tall. I think I'm about 1.6 metres, which is probably a bit shorter than average, but I'm going to go with 1.6 metres for the average height of a man. For part B, find an estimate for the real height in metres of the tree. Okay, well, let's see how many of these men do we think would fit on the tree? So you could actually measure it. So he's about, what's that? 8 or 9 millimetres, probably 9 millimetres. What about the height of the tree? Well, this is about 49 millimetres. Okay, so we're doing estimates. So I'm going to say that's about 50 millimetres. And this is about 10 millimetres. Okay, so rounding to the nearest 10 millimetres. So how many men would fit in the height of the tree? Well, 50 divided by 10 is going to be 5. So if we're saying that the height of a man is 1.6 metres, then the height of the tree is going to be 1.6 times 5. So 5 times 6, 6, 12, 18, 24, 30. 1 times 5 is 5, plus a 3 is 8. Put our decimal point in. We've got an estimate of 8 metres for the height of the tree. Question 14. Year 9 students from Hale School were asked to choose one language to study. The table shows information about their choices. So 56 students chose French, 40 chose Spanish, and 24 students chose German. Draw an accurate pie chart to show this information. Okay, so if we're going to draw a pie chart, we're going to need to work out our angles. So the first thing we want to do is know how many students we've got in total. So if we add these up, 6 plus 0 plus 4 is 10, 5 plus 4 is 9, plus 2 is 11, plus 1 is 12. So we've got a total of 120 students. Now that's nice because we're going to have to work out our angles, and we know the total number of angles in a circle are 360 degrees. Now, some of you might be able to just spot this. We're looking at how we can get from the number of students up to the number of angles. So what we're going to do is we're going to take the total number, 360, and divide it by 120. Well, the first thing we can do is cancel the zeros, and hopefully you'll see, well, 36 is in the 12 times table. In fact, 12, 24, 36. It's the third number in the 12 times table. So that means if we want to work out the number of angles for each of these languages, we're going to need to multiply the number of students by 3. So let's call this degrees. Okay, so 56 times 3. 3 sixes, 6, 12, 18. 3 fives, 5, 10, 15. Plus 1, 16. Spanish. Well, this one's a bit more straightforward. 4 times 3 is 12. And the 0, 120. And for German, we want 24 times 3. 3 fours, 4, 8, 12. 2 times 3 is 6, plus 1 is 7. Okay, so we've got the angles that we need for each of the languages. Now we've got to draw them on the pie chart. So we're going to need our protractor. You can do the languages in any order. I'm going to just do them in the order that they've been given. So for French, we need 168 degrees. And they've given us our starting line. So I'm going to get my crosshairs, put it on the line here, and line this up here. So we're starting on this line, so this is going to be 0. So we're going to go 0, 10, 20. We want to go all the way around to 168 degrees. So, I moved it. Let's get that back. So this would be 160. 170 is there, so that would be my 168. And then I can just use this to draw a straight line up to the edge. This is going to be French. Okay, sorry, I didn't really show it when I was doing the... Not sure how well you could see that protractor there. But if I show you, you should be able to see that lines up with 168 on there. Now for Spanish, we've got 120 degrees. So now we're starting with this point as our starting line. If I wanted, I could go up here and start from 0 around that way. But I'm going to start from where we've got to so far. Here, line it up. So because we're starting from here, this is the angle we're trying to measure, 120 degrees. I need to be ambidextrous for this, really. 0 all the way around, 120. Mark that here. Join it up with a straight line. So this is our Spanish. So what's left should be German. And we can check, we've done it okay, because this angle should now be 72 degrees. So I'm going to put that on there. Now it doesn't matter if you're out by 1 or 2 degrees, but you want to be as close as you can. 72 degrees. So 0, 10, 20, 30, 40, 50, 60, 70, 1, 2. Yeah, pretty much spot on. And that's what we need. Okay. Now, Year 9 students from Lowry School were also asked to choose one language to study. This accurate pie chart shows information about their choices. Okay, so you can see the bigger section is French, then Spanish, then German. Shamina says the pie chart shows that French was chosen by more Year 9 students at Lowry School than at Hale School. Is Shamina right? You must explain your answer. Well, if you remember with the previous school, Hale School, we had the pie chart, but we also had the number of students there. With Lowry School, they haven't told us anything about the number of students. So we can't tell. So the pie chart doesn't tell us this, because it doesn't give any information about the number of students. And that's all we need to write. Is Shamina right? No, because she's saying the pie chart shows that French was chosen. It doesn't, because there's not the information. So, no, we are not given any information about the, and this is the important bit, it's about the number of students at Lowry School. Yeah, we might only have 10 or 20 people at Lowry School, so it's not going to be the same as if there were hundreds or thousands. Question 15. Here are a triangle and a rectangle. Triangle, rectangle. The area of the rectangle is 6 times the area of the triangle. Work out the width of the rectangle. Okay, well the area of the triangle is half times the base times the height. Or in other words, it's half times 8 times 9. Half of 8 is 4. 4 9s, 9, 18, 27, 36. And its area, so it's going to be centimetres squared. Right, we know the area of the rectangle is 6 times the area of the triangle. So if we multiply this by 6, it'll tell us the area of the rectangle. So we want 36 times 6. 6 times 6, 6, 12, 18, 24, 30, 36. 3 times 6, 6, 12, 18, plus 3, 21. So the area of the rectangle is 216 centimetres squared. Now we know that for a rectangle, the area is the length times the width. We know the length, so the width must be the area divided by the length. So in other words, it's 216 divided by 16. This would be very easy if we had a calculator, but we haven't. Not allowed to use it in this paper. So we want to work out 216 divided by 16. So I'm going to start with what I know, and I know that 10 16s are 160. And if I add on a 16, 6 and 1 is 7, we get to 176. So let's try and add on another 16. 6 and 6 is 12. 7, 1 and 1 is 9. 192. So we're getting closer to it. Let's add another 16 on. 2 and 6 is 8. 9 and 1 is 10. 1 and 1 is 2. 208. We're almost up to 216. So this is adding on 1, 2, 3. So this is up to 13 times so far. Now from 208 to 216, we've got 209, 10, 211, 212, 213, 214, 215, 216. So we've got 8 left over. Well, if you think it's 8 out of 16, well, 8 is half of 16. So it's going to be 13 and a half, or 13.5 times. So that is going to be our width. If you've got another way of dividing it, absolutely fine. This seems to be just a nice way of doing it. Okay, question 16. V equals U plus AT. U equals 1, E equals minus 3, and T equals a half. Work out the value of V. Well, let's substitute all the values in first of all. So V is equal to U, which is 1, plus a, which is minus 3, t times a half. Okay, well, 1, we keep the 1. When you get a plus and a minus, the minus is going to win, so that's going to be minus or subtract. And 3 times a half, or 3 halves, you'd have a half, a whole, 1 and a half. So 1 minus 1 and a half. Or if you think with a number line, that's 0. If this is 1. If you're trying to take off 1 and a half, well, taking off 1 is going to get you back to 0. Then you've still got a half to take away, which is going to take you to minus a half, or minus 0.5. So minus, they've written their values as fractions, so I'm going to keep that as a fraction this time. But it would still be okay if you wrote it as minus 0.5. Okay, 17. 5 tins of soup have a total weight of 1,750 grams. 4 tins of soup and 3 packets of soup have a total weight of 1,490 grams. Work out the total weight of 3 tins of soup and 2 packets of soup. Right, so I'm going to write this using a bit of algebra notation. So 5 tins, so I'm going to say 5t equals 1,750. And 4t plus 3p, 3 packets, equals 1,490. We want to know the total weight of 3t plus 2p. Well, from this one, we can work out what t is. If we know 5t is 1,750, t must be 1,750 divided by 5. Or if we do it using the bus stop method, we can say 5 into 1 doesn't go. 5 into 17, 5, 10, 15, that's 3 times. 16, 17, so 2 carried over. 5 into 25, 5, 10, 15, 20, 25, that's 5 times. And 5 into 0 is 0. Right, so we've worked out what t is equal to. What we can do with that is we can substitute it into here. So we're going to want 4t. So we want 350 times 4. 4 times 0 is 0. 4 times 5 is 20. 4 times 3 is 12. Plus 2 is 14. So if we put that into here, we've got 1,400. That's our 4t. Plus 3p, because we don't know what p is yet, is equal to 1,490. So we can work out what 3p is. Because if we move this to the other side, we're going to take it off. We're going to end up with minus 1,400. Or in other words, 3p. Well, if you think 1,490 minus 1,400, we're just going to be left with the 90. And so 1p, we're going to need to divide it by 3. Well, 9 divided by 3 is 3. So we're going to get p equals 30. So now for this that we've been trying to work out, we've got 3 times t, which is 350, plus 2 times p, which is 30. So let's do our 350 times 3 over here. 3 times 0 is 0. 3 times 5 is 15. 3 times 3 is 9. Plus 1 is 10. So we've got 1,050 plus, well, 2 times 3 is 6. Put the 0 on, 60. So all we need to do now is add these two together. Let's do this over here. 1,050 plus 60. 0 plus 0 is 0. 5 plus 6 is 11. 0 plus 1 is 1. And 1 plus nothing is 1. So we get an answer of 1,110, and that was grams. In fact, we can write that down here. Question 18. Bellina has a garden in the shape of a circle of radius 10 metres. He's going to cover the garden with grass seed to make a lawn. Grass seed is sold in boxes. Each box of grass seed will cover 46 metres squared of garden. Bellina wants to cover all the garden with grass seed. Work out an estimate for the number of boxes of grass seed Bellina needs. You must show you're working. Right, so we're going to want the area, and the area of a circle is pi r squared. Okay, pi, we can use 3.14, r squared, so that's going to be r, which is 10, the radius, times another 10. Okay, now because they want an estimate, I'm going to say, well, 3.14 is approximately equal to 3. So we're going to round it. So we can say that this is all approximately equal to 3 times 10 times 10, which is, well, 10 times 10 is 100, times 3 is 300. Okay. And each box will cover 46 metres squared. Well, 46 is approximately equal to 50. Okay, we're just rounding it to the nearest 10 to make it nice and tidy. So to know how many boxes we need, well, we want 300 divided by 50. Well, we can cancel a 0 there and there, so we've got 30 divided by 5. Well, 5, 10, 15, 20, 25, 30, that's 6 times. So that's going to be our estimate. We can write it down here. Is your estimate for part A an underestimate or an overestimate? Give a reason for your answer. Okay, well, for the area, we can say we rounded down for the area of the garden. So assume that was slightly smaller than it was. But for the seed, we rounded up for the coverage of seed. So if we're saying our denominator is smaller, or let's write it this way, smaller, but our denominator is bigger, well, that means that we're going to be getting a smaller answer overall. So it's going to be an underestimate. Yeah. Because if we went with the accurate numbers, it would be more something like 314 divided by 46. Okay, so if we know 50 goes into that 6 times, 46 is going to go into that more. Okay, so we underestimated. Question 19. A. Solve 4x minus 5 equals 18. First thing I'm going to do is I'm going to multiply out the brackets. You could move the 4 across, it's up to you. But I'm going to say, well, 4x minus 4 times 5 is 20 equals 18. So we want the 4x on its own, so we're going to move this over, so we're going to make that plus 20. So we're going to get 4x is equal to 0 plus 8 is 8, 1 plus 2 is 3, so 4x equals 38. Well, x is 38 divided by 4. So what I'm going to do here, I'm going to simplify this because I can see they're both even numbers. So I'm going to say, well, let's divide both of them by 2. So 38 divided by 2. 2 goes into 3 once, with 1 left over. 2 goes into 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. That's 9 times. So we get 19, and 2 goes into 4 twice. So we've got 19 divided by 2. Well, how many times does 2 go into 19? 2, 4, 6, 8, 10, 12, 14, 16, 18. 20 would be too many, so it's just 9 times. And once left over, but it's 1 out of 2. So we get 9.5. Okay. Minus 3 is less than t, which is less than or equal to 2. T is an integer, so a whole number. Write down all the possible values of t. Well, what's the smallest it could be? Well, t is bigger than minus 3, so it can't be minus 3. The next number bigger than minus 3 is minus 2. And the largest it can be is it can be less than or equal to 2. So the biggest it can be is 2. So it can also be everything in between, so minus 1, 0, and 1. Okay, question 20. Asmol is paid £1,500 per month. He's going to get a 3% increase in the amount of money he is paid. Work out how much money Asmol will be paid per month after the increase. Right, so we want to work out 3% and then add it on to the original. Well, I'm going to start off by working out 1% of 1,500. If I wanted 10%, I'd knock off 1 0. If I want 1%, I'm going to knock off 2. So 1% is going to be £15. So for 3%, I'm going to multiply that by 3. 3 5s are 15. 3 1s are 3, plus 1 is 4. So the increase is £45. So we want 1,500 plus the 45. 5 plus 0 is 5. 4 plus 0 is 4. 5 plus 0 is nothing. Or 5 plus nothing is 5, sorry. And 1 plus nothing is 1. So £1,545. Question 21. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. We've got the maximum temperature up here on the y-axis and the number of hours of sunshine on the x-axis. And we're told one of the points is an outlier. Write down the coordinates of this point. So the outlier means it doesn't fit in with the pattern of the rest of the data. Well, the data's following this pattern. This one is clearly the outlier. So we want the coordinates of that. Well, we want the x-coordinate first. So let's track this down here. It's halfway between 9 and 11, so that's going to be 10. And halfway between 18 and 20, so that's going to be 19. So the coordinate, always x first, is 10, 19. For all the other points, write down the type of correlation. So we have 3 types of correlation. We have positive, which means as one of the variables increases, so does the other one. So going up, so this is our positive correlation. Negative correlation would mean as this increases, this one goes down, so we'd get something like that for negative. No correlation would mean, well, it could be a vertical line or a horizontal line or just totally random values. So in other words, there's no connection between the two. But this is clearly positive. And then we're told that on the same day, in another British town, the maximum temperature was 16.4 degrees. Estimate the number of hours of sunshine in this town on this day. So to do that, we're going to need to draw a line of best fit. Okay, and the way we can do this is we want a straight line using a ruler which goes through this data, and we want it to have roughly the same number of values on one side as the other and following the overall shape of the data. So let's see, where's that going to be? Something like this. And there's going to be more than one right answer to this as well. So where can we, let's go something like this. Okay, it doesn't have to go through any of the values. If it does, that's okay, but it doesn't have to. And they wanted, what did they want us to work out? The maximum temperature was 16.4 degrees. Estimate the number of hours of sunshine in this town on this day. So 16.4 degrees. Well, here's 16. Now we've got to work out what each of these values, these little boxes are worth. We know that's halfway between 16 and 18, so that's 17. We've got 1, 2, 3, 4, 5 boxes there, but the whole difference is 1 degree. So we almost want 1 divided by 5, or 1 over 5, which is 0.2. So in other words, 16.2 would be here, 16.4 would be there. So if we draw a line across from 16.4, we're getting here, which is, oh, it's very close. So I'm going to go with, I'm going to say that's 13 hours of sunshine. Yeah. And then a weatherman says temperatures are higher on days where there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. So temperatures are higher on days where there's more sunshine. Well, there's more sunshine on this side. And yes, the temperatures are higher. So let's say yes, give a reason, and well, it's sort of what we said already. We can say there's a number of hours of sunshine increases, so does the temperature. Question 22. Express 56 as the product of its prime factors. So prime factors, well, factors, numbers that go into 56 without any remainder. Prime factors means we want to keep going until we haven't got any more numbers we can divide into those. Well, it's it's an even number, so I know 2 is going to go into it. So how many times does 2 go into 56? Well, 2 goes into 5, 2, 4, twice with 1 left over. 2 goes into 16, 2, 4, 6, 8, 10, 12, 14, 16, 8 times. So 2 and 28. I can't go any smaller than 2, because 2 is prime. 28, that's still an even number, so I know 2 can go into it again. And how many times does 2 go into 28? Well, 2 goes into 2 once, 2 goes into 8, 2, 4, 6, 8, that's 4 times. So we've got 14. This is a prime number, so we stop on this branch. But 14, it's even again, so I know 2 can go into it again. And how many times does 2 go into 14? Well, 2, 4, 6, 8, 10, 12, 14. That's 7 times. 2's prime, 7's prime, so we stop there. So we want 56 equals, because we're expressing it as the product of its prime factors, so it's equal to 2 times 2 times 2 times 7. Yeah, 23. Work out 54.6 times 4.3. Now everyone's going to have a different way of doing their multiplication. So I'm going to do it the column method, but it's entirely up to you how you do it, so long as you get the same answer. So 3 times 6 is 18. 3 times 4, 4, 8, 12, plus 1 is 13. 3 times 5, 5 times 15, plus 1 is 16. Now we're going to move on to the 4, so we put a 0 here. 4 6s, 6, 12, 18, 24. 4 4s, 4, 8, 12, 16, plus 2 is 18. 4 5s, 5, 10, 15, 20, plus 1, 21. So we're going to add these together. 8 plus 0. Sorry, did I miss something there? No, 8 plus 0 is 8. 3 plus 4 is 7. 6 plus 8 is 14. 1 plus 1 plus 1 is 3. 2 plus nothing is 2. But we're going to put our decimal point back in. We've got one decimal place here, another one there, so that's 2 decimal places. So we're going to move it 1, 2 into there. So we've got an answer of 234.78. So it's up to you how you want to do your multiplication, as long as you've got a nice method that's clear and gives you the right answer. Question 24. The area of square ABCD, so ABCD, the square here, is 10 centimetres squared. Show that x squared plus 6x equals 1. So with these, it's not always clear where to start. I'm just going to think, well, how would I write the area of this shape? Well, the area of a square is going to be the length times the width. Well, the length is going to be 3 plus x. So let's do area equals length times width. Okay, so length is 3 plus x, but the width is also 3 plus x. So we're going to multiply them by each other, length times width. So 3 times 3 is 9. 3 times x is 3x. X times 3 is another 3x. And x times x is x squared. So let's rearrange that. Let's put the highest term here, so the x squared. 3x plus another 3x is 6x. And then we've got plus 9. But we're told the area of the square is equal to 10. Okay. Now, to get it to look like this, we haven't got any sort of constant value on the left. So we can move the 9 across here and make it a minus 9. So we get that x squared plus 6x equals 10 minus 9, which is 1. So we've shown it. Question 25. This rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame. Okay, so we want to know how much metal we've got to start with. So we've got 12 meters here, 5 meters here. This is going to be another 12 meters. This is going to be another 5 metres. How long's this? Well, if we think of this as a right angle triangle, which it is, we can use Pythagoras. Okay, so if we label this A, and this B, and this C, and we know that A squared plus B squared equals C squared. Or in other words, 5 squared plus 12 squared equals C squared. 5 squared, so 5 fives are 25. 12 squared, hopefully you'll know this one. If not, you can work it out. You could maybe start with 10 times 12 and then add 2 more 12s on. But you'll get up to 144. And that equals C squared. So let's add 144 and 25. 4 plus 5 is 9. 4 plus 2 is 6. 1 and nothing is 1. So if I now swap them over, I've got that C squared is equal to 169. So C on its own is going to be the square root of 169. Well, we know that 12 squared is 144, so we can try working up from there. If we add another 12 to it, we get 156. And then that would be 12 13s. If we add another 13 to make it 13 13s, 156 plus 13 would get us up to 169. So the answer is 13. So what I was trying to say there was we can do 144, we can add on a 12, and then add on a 13. And we could repeat that process if it was a bigger number to keep going. But hopefully you'll be able to look at it. You can see it's an odd number, so it means it must be, the square root must be an odd number as well to get that answer. And we've got 13 there. Right, so we know this is 13 metres. So we want to get the total distance. So we've got 5 plus another 5, 12 plus another 12, and then we've got 13. Well, 5 plus 5 is 10, plus 12 is 22, plus 12 is 34, plus 13 is 47 metres. That's the length. We want the weight, and the weight is 1.5 kilos per metre. So we want 47 times 1.5. Well, I'm going to split this up and I'm going to say, well, it's the same as 1 times 47 plus 0.5, or a half of 47. So a half of 47, we're going to do 47 divided by 2. 2 goes into 4 twice. 2 goes into 7, 2, 4, 6. So that's 3 times. And actually what I'm going to do here, we've got 1 left over, so we're going to put a 0.0 on the end and put our 1 carried over here. Put a decimal point. So now it means we've got something to divide the 2 into. So instead of having remainder, we can say, well, how many times does 2 go into 10? 2, 4, 6, 8, 10. That's 5 times. So we've got that 1 times 47 is 47, and a half of 47 is 23.5. So if we add these two together, and I'm going to put a 0.0, so I've got something to add to. 0 plus 5 is 5, 7 plus 3 is 10, 4 plus 2 plus 1 is 7. So we've got 70.5 kilograms. Now we've got question 26. The equation of the line L1 is y equals 3x minus 2. The equation of the line L2 is 3y minus 9x plus 5 equals 0. Show that these two lines are parallel. Okay, so if you remember, the equation of a straight line is y equals mx plus c, where m is the gradient. So if we want to show that two lines are parallel, we want to see that m is the same for both of them. Now, L1 is already in this format. We've got y equals a number with x, and then we've got a constant at the end. Line 2, we've got 3y. We want just one y. So we kind of want to divide everything by 3, really. Well, 3 divided by 3 would just be 1. So just get y. 9 divided by 3 would be 3. And 5, well, we can do 5 over 3 equals 0. Okay? So now it's looking a bit closer to this format. But we want y equals. We've got y minus. So if we want equals, we need to move this to the other side. So the minus 3x is going to become a plus 3x. And the plus 5 over 3 is going to be a minus 5 over 3. So in other words, we get y equals 3x minus 5 over 3. Now the minus 5 over 3 doesn't really matter, because to know they're parallel, we just need the gradient to be the same. So we can say the gradient of L1 is 3, which is here. And the gradient of L2 is 3. So the lines are parallel. Okay. And the last question we've got here, question 27. Okay. ABCD is a parallelogram, and they've drawn it here for us. The diagonals of the parallelogram intersect at 0, so they cross there. OA equals A, so that's here. And O to B equals B, up there. Part A, find in terms of B the vector DB, so D to B. Well, this section must be the same as this section. So we've got B and another B, which is just 2B. Now part B, find in terms of A and B the vector AB. So we want to start from here and get to here. Well, we can go down this way, but this is going backwards on A, so it's going to be a minus A. That looks like a 9. On a minus A, and then up here, which is B. So we're going to have minus A plus B, which you could write as B minus A if you want. Either one would be fine. And C, find in terms of A and B the vector A to D. So from A to D, we're going to have to go down here again, which is a minus A, and then we're going to need to go down this way to get to D, which is going to be a minus B. So minus A going backwards, minus B going backwards again. So minus A minus B. And that's the end of the paper. So I hope you found it helpful. Please subscribe to the channel, like the video, have your notifications on so you find out when I load more videos, and I look forward to seeing you again soon. Thank you.